So today is going to be a say out loud session for early human development. So what I want you to do is either copy after me or use me as an example, but I want you to go and read this part out loud and try to make stories and vignettes in order to help you. So we're going to start off in the gonads, and we're going to start off in the 5th and 6th weeks of life. And this is where the male and the female starts to differentiate. So you have the spermatogonia, and the oogonia goes into meiosis 1 to develop into primary spermatocytes or primary oocytes. And you have to remember that meiosis 1 and 2 are divided into PMAT, which is prophase, metaphase, anaphase, and telophase. And this is just basic stuff that I'm telling you about right now. So you have to remember that meiosis 1 consists of synapses, chromosomal crossover, alignment disjunction, and cell division, and ending with 23-2N. And in general, you can go into more details of this, like what is actually going on in synapses and the chromosomal crossover, and looking at the pictures and thinking about things like when non-disjunction happens and how this can cause baby to have abnormalities. And then meiosis 2 does not have synapses or crossover events, but does have alignment, disjunction, and cell division. You also need to use this time to think about the disjunction in meiosis 1 and meiosis 2. One is without splitting and one is with splitting of the centromere. So now we're going to move on. We're going to move on to the male. So in the male, the premotor cells are dominant, or not dominant, but dormant at week 6 until puberty. Then spermatogenesis and meiosis 1 begin at puberty. You're going to have type A and type B spermatogonia. And these will be in the seminiferous tubules of the testes. Remember that A spermatogonia makes B. They're basically cells that just keep making themselves just to make B. B spermatogonia undergoes DNA replication and then enters meiosis 1, forming primary spermatocytes, which will be 4N. Remember, that is 4N. Then will form secondary spermatocytes and go into meiosis 2. After meiosis 2, secondary spermatocytes divide and form haploid spermatids, which is 23-1N. Then spermatogenesis occurs where the spermatids develop into mature spermatozoa, and this process is continuous throughout life. Then we're going to move on to the female. Female is the 4th through the 6th week of development. Premotor cells migrate and differentiate into oogonia, which is 4-6-2N. Rapid cell division happens over the next few months, and then gametogenesis begins in the fetal ovary during the 4th and 5th month of development. By the primary oocytes, 4-6-4N. It would have 4-6-4N, and making about 7 million cells. This is where primary oocytes arrest for the first time in prophase of meiosis 1 until puberty. At puberty, there's 5 to 15 oocytes, and they will unrest, but only one will complete the meiosis 1 and form secondary oocytes, which will be 23-2N. And remember, the first polar body degenerates. The second oocytes develops within the Graafian follicle in each monthly cycle. Once ovulation occurs, the secondary oocyte will arrest the second time, and metaphase of meiosis 2. That's very important. You might get a question like that, like where after ovulation, where or what part of meiosis 2 does the secondary oocyte arrest? And you would say metaphase of meiosis 2. So if fertilization occurs, the secondary oocyte will become unarrested and complete meiosis 2 to form an ovum and another polar body. If no fertilization occurs, then there will be degeneration and no completion of meiosis 2. And then this continues each month with the bleeding, unless a woman gets pregnant, and this goes on until menopause. So it's also important to know what's going on with the gonads week by week. So week 3, there's the intermediate mesoderm forms. Week 4, the formation of the urogenital ridge and indifferent gonads appear. Week 5, the primary sex cords. And then week 4 through 6, there's the population of the primary sex cords of the indifferent gonads. Then you have week 7 through 8, which is the differentiation of testes or ovaries. Then you have week 9 through 12, which is the external genitalia distinction. Then you move on to development, which begins in the 4th week, and this is the paired longitudinal ridges, which is the urogenital ridges of the intermediate mesoderm on the dorsal wall of the embryo. This development begins at the T10 level. So now you have the primordial cells, and they are very important for the development of the gonads. These cells stimulate gonadal ridge epithelium to form Sertoli cells, and this is the cells that are for males and help distinguish a male, and the follicular cells, which is for females and help differentiate a female. Then you have the primordial cells also populate and invade the sex cords by the 5th and 6th week. Different ducts form for the male and the female. For the male, it's the menophoric ducts, which are also called the Wolffians, and they help develop the male genital tract, and this is influenced by testosterone. This is very important to know. Then you have the paramesonephric ducts, which are also called the Mullerian ducts, help in the development of female genital tracts, and is influenced by estrogen. So now we're going to go into the actual development of the testes. The testes start off, the stride gene encodes for testes determining factors, which you will see as TDF, and this triggers the development of the Sertoli cells, as I was just telling you about, and directs development. The Sertoli cells produce Mullerian inhibiting factors. You want to remember that this needs to be inhibited because Mullerian helps develop the female genital tract. So we want that to be prevented. The Leydig cells produce testosterone by the 8th week. With the presence of testosterone, the sex cords elongate, become tubular, and develop seminiferous tubules at puberty. Some testosterone is converted to dihydrotestosterone, which is DHT, by enzyme 5-alpha reductase, which is responsible for the development of external genital or genitalia in the male. And you want to remember all of these different, like dihydrotestosterone and the enzyme 5-alpha reductase, because when certain things are not right, it can cause different things such as like pseudohermaphrodism and stuff like that. So within the male, we want to know what forms the external genitalia, such as the genital tubercle forms the body and glands of the penis. The urogenital, which is the urethral folds, form ventral aspect of the penis, and the labioscrotal swelling forms the scrotum. And you can see some anomalies in the male external genitalia, like the hypospadias and the epispadias. Hypospadias, remember, is below, so it's the ventral surface, and usually due to the low levels of DHT. That's why I was saying that it's important to remember the dihydrotestosterone and how if it's affected, it can cause the hypospadias. And with the epispadias, it's the dorsal surface and associated with extrophy of the bladder. Now we're going to move on to the ovary, which is the primary cords, are replaced by a second generation of cords from the primordial follicles that house the primary oocytes. The paramesenephric Mullerian ducts contribute to the formation of the uterine tubes, uterus, and upper third of the vagina. Cranial ends form the left and right uterine tubes, while the lower ducts fuse in the midline to form the uterus and the superior one-third of the vagina. The mesenephric ducts degenerates after final rows of development of the final kidney. So for the external genitalia of the female, the genital tubercle forms the clitoris, urogenital urethra folds forms the labia minora, and the labiosacral swelling forms the labia majora. For female, now, here's some more anomalies that you may find, and this goes back to things such as the enzyme 5-alpha reductase and DHT and all the different things that can cause the female pseudo-intersexuality, the male pseudo-intersexuality, or the androgen sensitivity, as I was trying to explain to you earlier. So female pseudo-intersexuality, you will see 46XX, and you'll see normal reproductive organs, but there will be a masculinized genitalia due to excess androgen production from congenital adrenal cortical hyperplasia. For the male pseudo-hyperintersexuality, you will have a 46XY, but there will be like a stunned development of the male genitalia development due to reduced production of testosterone and 5-alpha reductase deficiency. There goes the testosterone and the 5-alpha reductase deficiency that I was telling you about. And then for the androgen insensitive syndrome, you'll have a 46XY, you'll have testes, but there'll be female phenotype. Testes will need to be removed to prevent a tumor. Then MIF will be present. That's why you won't have the internal female organs being made. But this child will usually be raised as a female because their outside external genitalia will look like a female. They'll probably have like a closed vagina, but they'll still have the outside appearance of a vagina. But they will lack androgen receptors.